Hello and welcome to all students. In this lecture, we'll learn about elementary probability theory. So, basic of probability theory we will learn here. So, probability, the word probability is derived from the word probable. Probable, we know that. Okay. When the outcome of any event is not certain, the theory of probability enters the sense. For example, when a coin is tossed, whether it will show head or tail is not certain, and we say that probability or probably it may show a head or may show a tail. The theory of probability calculates the chances of occurrence of an outcome. Consider the example of a coin. For a fair toss, it is anybody's guess that the chances of occurrences of a head or a tail are equal. That is 50% 50%. However, this is just a common sense. The same common sense supported by theoretic principle enfolds the fascinating world of probability theory in front of us. So let us learn and enjoy the concept of probability. So first of all, we see some basic terminologies. So first basic terminology is the random experiment. So let us write first random experiment. So any random experiment is any action which result is uncertain, not pre-decided, is called a random experiment or trial. Each result of the experiment is called an outcome of the experiment. Okay. So for example, tossing a coin is a random experiment, and after tossing a coin we get a result either head on the upper face or tail on the upper face. So if we get a head, then it is called as outcome, or if we get a tail, it is also outcome. So outcome of that experiment. Okay. Now let us go to the next terminology, and we call it is a sample space. Sample space. So sample space means it is the set of all possible outcomes of an random experiment. For example, tossing a coin is a random experiment. I will write here tossing coin. A coin. So there are many random experiments. Tossing a coin is one random experiment. Okay. And its sample space. Samples means space means all possible outcomes. If we toss a coin, we get either head or tail. So these are the two possible outcomes, and we make a set of these two possible outcomes, and we call it is S. S means sample space. So sample space is the set of all possible outcomes of a random experiment. Okay. So the set of all possible outcomes of an experiment or trial is called a sample space of that experiment, and it is denoted by capital S. And this set is also called as the universal set for the said experiment. Okay. And N of S means the total number of elements or total number of outcomes of that random experiment, and here there there are two. Okay, so let us write one more example of a sample space. So this is one example, tossing a coin, single coin. We write a second example. Three coins are tossed. Three coins are tossed. Each coin give one of the two results. Okay, so random experiment is three coins. Three coins are tossed. Then what will happen? So then the upper face of each coin will give one result. So suppose first result is all three coins will give head on the upper face. Okay, this is one possibility. Second possibility is this coin gives head on the upper face, this coin gives head on the upper face, this coin gives tails on the upper face. Okay, then this coin gives head, this coin gives tail, this coin gives head. Next possibility, tail, head, head, or all will give a tail on the upper face. Okay, so how many possibilities are there? Okay, TTH or THT or HTT. So 1, 2, 3, 4, 5, 6, 7, 8 possibilities are there. So sample space S is equal to, it is the set of first possibility, second, third, fourth, fifth, sixth, seventh, and this is eighth possibility. So n of S is equal to 8. So this sample space contains 8 outcomes. 8 outcomes. Okay. Now we define the next terminology, and we call it is event. Event of a sample, event of an random experiment. Okay, so next terminology is third, we call it is event. So see here, for example, random experiment is a tossing a coin and getting head on the upper face is a one event, getting tail on the upper face is a second event. Okay, so random experiment is a tossing coin. Suppose tossing a coin, random experiment, sample space is HT and its event is event of getting head on the upper face. Okay, so that event, let us we give a name to that event, we call it is A be the event of getting head, and this A is the set of head only. So event is always a subset of sample space. Okay, so one more event I will write, event of getting tail, event of getting event of getting tail means T on the upper face, and we call this event B. Therefore set B contains only one element. Okay, so this is one example of random experiment and its event. Okay, so we can have more random experiments and their events. A tossing of 3 coins and getting heads on the upper face is a one event. Getting tails on the upper face is a one event. So there are two types of events. First is impossible event and certain events. Two types of events. First is impossible event. And second is certain event. Okay, so it is possible that the event with empty element, that is null set, such an event is an impossible event and n of p is equal to 0. In this case, the other extreme case is E naught s. Okay, so for example, let us take an experiment of tossing a coin, random experiment, and getting 5 on the upper face is impossible event. Okay, now next is certain event. So in the experiment of tossing a coin, getting either head or tail is a certain event. So there are some standard examples. Tossing of a coin, this is already discussed. Okay, throwing of a die. Okay, so this is new example. So throwing of a die. Let us take some examples now. Throwing a die, cubic die. Throwing a cubic die. So we know that what is that cubic die. If we throw this die, then we get either 1 on the upper face, 2 on the upper face, or 3 on the upper face, or 4 or 5 or 6 on the upper face, because cubic die has 6 faces, and on all these 6 faces there is a numbering from 1 to 6. And so if we throw that die, then there will be one number on the upper face, and possible numbers are 1 2 3 4 5 6, and so this forms a sample space for this random experiment. Okay, sample space. Now let us take A to be the event of getting even number on the upper face. Event of getting even number on upper face. Therefore, the elements in set A are 2, 4 and 6. So this is the event of getting. Okay, random experiment, sample space and its event. So total number of elements in sample space S are 6 and total number of elements in the event A are 3. Okay, let us take the next event in this experiment. Let B be an event of getting odd number on upper face. So therefore B has an element 1, 3, 5, 1, 3, 5, and therefore total number of elements in B are again 3. Okay, let us write one more event. So the notation for events are we use the capital letters A, B, C, D to denote the events. Okay, let C be the event of getting number which is divisible by number divisible by 3, number divisible by 3. Therefore C contains the elements. First element is 3, second element is 6, and therefore the total number of elements in set C are 2. Okay, 1 and 2. Now let us define the concept of probability now. Okay, now define the concept of probability. Okay, so let us write the definition. If capital S is the finite sample space of an experiment, first of all we write definition. If capital S is the finite sample space of an experiment, finite sample space of an experiment and every outcome of S is equally likely, and every outcome of S is equally likely. And if E is an event, and if E is capital E is an event of that random experiment, then the probability that E take place is defined as then 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 the probability that E take place is given by probability of getting event E is equal to number of outcomes in event E divided by number of outcomes in sample space S. So this is the simple definition of probability, and that is very important. While solving the problem. Okay. 1 minute. Okay. Probability of getting event E is equal to n of E divided by n of S. N of E means number of outcomes in event E divided by number of outcomes in event S in the sample space S. Okay. So now let us take one example. Now let us take one example. Example. So example, let us take one experiment: tossing a die, throwing a die, throwing a cubic die. So we know that its sample space is 1 2 3 4 5 6, and it has 6 elements. Okay, and let us take A be the event of getting even number on the upper face, even number on the upper face, even number on the upper face. Therefore the event A has these outcomes 2 4 6, and the total number of elements in the event A are 3. Okay, therefore can we write the probability now? Therefore probability of occurring event A is given by number of outcomes in event A divided by number of outcomes in sample space. Okay, so number of outcomes in event A are 3 and number of outcomes in sample space are 6, and therefore it is equal to 1/2. Therefore we can say that the probability of occurring event A is 1/2. So there is half chance to occur the event A. Okay, half chance. So let us take one more event now. Let us take one more event in this experiment. Second, let B denote event of getting number divisible by 3, number divisible by 3 on the upper face of die. So B contains the outcomes. First outcome is 3 and second outcome is 6. Only two numbers which are divisible by 3. Therefore number of elements in B are 2, and therefore we can write the probability of occurring event B. By definition, it is number of elements in B divided by number of elements in sample space S is equal to number of elements in B are 2 and sample space has 6 elements, therefore it is equal to 1 by 3, and thus probability of getting event or occurring event B is 1 by 3. Okay, is 1 by 3. So in this way we can find the probability of an event for a given random experiment. So let us end this lecture here. Okay, thank you for paying attention. Okay, thank you very much.